I actually would like to introduce our guest, Anouk Wipprecht, a high-tech fashion designer and educator. And in her work, she combines fashion and technology by using elements of robotics, machine learning, and sensors. And she has collaborated with a number of well-known brands and companies, including in automotive industry, tech, and entertainment, such as Audi, Volkswagen, Microsoft, Philips, and Disney, just to name a few. What is even more notable is that very early on in her journey, she was able to conceive a vision of her own that clothing can be interactive and embark on a successful journey in realizing this vision.
My name is Anouk Wipprecht. I'm originally from the Netherlands, from a place called Beemster, a small place up in Amsterdam. And currently I live in Miami in the United States. And yeah, I've been combining fashion and technology since the beginning of 2000. I came from couture tailoring garments. I thought it was really interesting that people early on, like through clips like MTV and crossovers from America, were expressing themselves through garments. And so I got really fascinated by that. So I attended fashion school. That was not enough for me because for me, the garments that I was making were analog. So when I was 17 years old, I got interested in robotics and electronics, and I have been combining those ever since. So I work with sensors, microcontrollers, and design and the body. You can find me under my name, Anouk Wipprecht. If you have questions later on, feel free to drop me some there. And I'm going to explain a little bit about my research, take you through some process and R&D, and also talk about body signals. So the first thing that I want to start with is that I work with the spaces around the body. I work with the spaces around the body and also with the body itself, so body signals. If you're thinking about spaces around the body, you have the intimate, the personal, the social, and the public space around you. We all have that sort of, and then culturally or personally or emotionally or whatever, that can influence whoever you might want to have in your personal space, for example. This is the proxemics theory of Edward T. Hall, and I got really interested in that halfway 2000 because it really had to do with the things that I was busy with at that time. I was doing focusing on interaction design. And it had a really big relation to these spaces that we have around us, sort of. Edward T. Hall was measuring this in an analog way with a wooden stick. And what I'm using is sensors. So I took his research and I am measuring these distances by the use of sensors. And this is an old one. I could not find the sensor that I'm using, ultrasonic rangefinders. This is a more cheaper sensor. It's an ultrasonic sensor. So I'm basically interpreting his research and correlating that and measuring that by things like proximity sensors and such. So in one of my works that you can see that is the dress that I have behind me is the robotic spider dress. It's a dress based on these spaces, sort of these spaces that we have around us, and ultrasonic rangefinders that are doing those measurements. So when somebody steps into the personal space, the system is reacting, and it reacts in something that I call 12 states of behavior. So depending on your speed and where you're standing in front of this design, it's choosing between one of these states, and they can go from very gentle to very aggressive, So it basically chooses one of those states based on your interaction with this dress. The dress is based on little servo motors, so I'm using Hobby King servos in there. So I have here like a little prototype. So the servo would be in here and in here. So in one leg, in this case, there's two. In the side legs, there are 3 of them. So this is basically how the mechanism is moving, and it also moves this way. And in robotics, we talk about degree of freedom. So the more degree of freedom your design has or your robot has, the more you can do with it. And this is why I looked at the mechanism of spider legs, which got really fascinating for me because you can create a lot of degree of freedom with this. So here it is. Sometimes I like to showcase the electronics, sometimes I like to hide them. In the case of the spider dress, I really want to show everything. I want to make it a very educative experience, showing the sensor, showing all the wires, the LEDs, the respiration sensor, and also the proximity sensors, which you can see here. And that's, yeah, sometimes the choice that I make between hiding it and really letting the sort of technology speak versus also really showing wires into my design. So I play a lot with that, with showing and hiding it. Another of my dresses is a collaboration with an Italian architect called Niccolo Casas, and he created the first 3D printed dress, the full 3D printed dress that I did with him about 12 years ago. So that was in 2010, 2011. And that's the smoke dress. So it's a dress based on sensors. And in this case, the more people are in the direct surroundings of the dress, the more smoke it gives away. And that's inspired by another animal, the octopus or the inkfish. It pushes out ink so it can almost escape. So that's the notion of the smoke dress. So again, using sensors measuring the surroundings, but in this case, measuring the density of the people around. And the more people around, the more smoke it gives. So this is the dress in my studio, just testing it out with certain kinds of it's a hot nozzle system with silicone fluids that I push out. In total, it were like multiple dresses controlled over the DMX system of the booth. So the light, the way you normally control light, was kind of the ideal way to do that. I was using an XP protocol, so Zigbee connected, so they were all meshed together. And then also another of my dresses is the robotic cocktail dress, which you can see here, which I created for and with Cirque du Soleil. Cirque du Soleil we know from the theater, but they also have nightclubs like in Las Vegas, and they have restaurants. And one of their restaurants is in Ibiza, and I got invited over to create, sort of food and technology and music kind of related project with them, and that became the robotic cocktail dress, which you can see here. It uses a peristaltic pump on the back of the design and a little push button. There's another one that has a game in there as well. You play a game of truth or dare, and that gives you the alcohol, or it doesn't. So you can see one of the dresses walk around. They were for boys and girls in multiple colors, and it was quite a fun project. This was in 2015. So with my with my research, I am researching if and when you place technology on the body, what does it do? How can it do more than just blinking and bleeping? How can it create some kind of consciousness almost? So how can these projects become social and playful, like the cocktail dress, defensive and behavioral, like the spider dress, or expressive and sensitive, like the smoke dress? So basically, I'm creating case studies with it, and then I'm proving out certain things that I have in my mind, and I try to prove them out, work them out, and then also work with them in a space and an audience and all of that stuff. So I have over, I think, 60 to 80 different dresses and projects, and I've been doing that over the last 20 years. And the main thing that I'm trying to research is, fashion really becoming this new kind of interface in where it can express you, or it can communicate something special about you. So I'm gonna go through this a little bit in steps. So I'm gonna tell a little bit about process, prototypes, collaboration, body signals, and close down with open source. So how my process looks like, and I took one of my earlier projects. This was in 2007 or 2008, in collaboration when I was doing an artist in residency at V2, Institute for Unstable Media in Rotterdam. And it became a project called Pseudomorphs, which is normally a sort of a morphing factor of a stone taking over another stone in rocks. So basically how my process looks like is the inspiration. What I wanted to capture in a garment was this movement of a drop in water. When you put a drop of ink in water, it makes this magical dance, which is really hard to almost capture. And that's what I wanted to do, sort of, so my first step is making like sort of an illustration. So at that time I was using like Photoshop. You can go now in 3D modeling and all of that stuff. This was 2007. So that's almost 15 years ago. I'm basically making your static image from that moment of inspiration to whatever you want to create. And mostly that sketch or whatever you're making is going to be like your red line through your project. Second step is trying to figure out how to work it out, how to make that magical moment appear in your garment. I was going actually to a close by hospital to feed to get maybe things that they had left, and they liked the products, and they gave me a lot of stuff that I still don't know what it is. It's a lot of like pain control things and devices and tubes and all of that stuff, which I later on worked into the prototype. I ended up using solenoid valves from Festo, which are normally for air pressure. At that time, they didn't have liquid valves, so I needed to use air pressure solenoid valves from Festo, which you can see here. So I could open them and I could close them basically. And here was the circuit board created in Eagle software, PCB design software. And basically the whole system was running on a 9-volt battery. It had a really big heat sink. This was not needed in the end, but it's always good for your first board to make sure that you have everything on there what you need, or what you potentially need, because of the creation of custom PCBs, printed circuit boards can be expensive. So it ended up being this dress with this neck piece. It was pushing through ink. I was putting different chemicals on the dress, so it created these stains, and I presented that during ICEA in Germany, in where basically a model, the dresses were basically bleeding this ink, and then I was hanging them all around the model as sort of a performance. We used it later with a stylist in Los Angeles for the clip for Britney Spears, Hold It Against Me. It was then a pressurized system really on her fingers. It was a cheaper material, so the soaking of the ink didn't really quite work well, but it was kind of cool to have that translated to that clip. At that time, I also moved to the United States. I did the Super Bowl halftime show in where I was creating for the Black Eyed Peas this outfits with high power LEDs, which you can see here. At the time I did more sculpting than 3D printing.
It's happening at the same time.
It's worse when they're hungry.
Yeah, it is.
Yeah.
More.
You always need to take in consideration multiple things, making it cool, making it smart, but also like what do you have to deal with and how does the design perform very well. In the case of the Super Bowl, there were a lot of lights on stage, and the design needed to be super visible. So that was one of the things that I really want to work on. So I used Wearable high power LEDs in this design, and also shoes with optic fiber that were like lighting up. And hoping that it was well visible on stage, which it turned out it was.
Had the time of my life, and I never felt this way before, and I swear this is true, and I owe it all to you. Oh, I had the time of my life.
I think you can find that online somewhere. So yeah, there's always a lot of things that you need to take in consideration, not only the space around you, not only the body, the design, the architecture of that, the coding and all of that stuff, but also like the environment that it will be presented in, sort of, but I like the sort of engineering kind of mindset for that, to figure that all out, depending on the client and depending on the project. Then prototyping. Prototyping, especially working with new materials, working with new pieces of electronics or software or whatever, you want to know what it does. You also want to know what it doesn't do, what it doesn't want to do, sort of, PLC stands for polymer dispersed liquid crystal, and it's basically a sort of a foil, tin foil that you can put in, you can put power over it. It switches in transparency. Normally we are used to seeing it now in between glass, but this was 12 years ago, and basically that whole community was creating this foil and didn't know what to do with it, that whole field. So they gave it a lot away to people to develop things with. So we started an art project with that. First of all, what we did was making them on doll. They were reacting to the body, which needed like a separate interface. The hip part was also not super ideal to like sit in, so we cut that back together, and we started to create dresses that had more the volume on the top part, which you can see here. So the dress below would have been like leather, and the top part is the foil in this case, which makes it easier like to sit with, because if you're sitting on foil, it of course it can break easily. So this became Intimacy 2.0. There's also quite provocative products around the material on the skin and the heartbeats and sort of the body signals of the wearer. So into collaborations, recent projects that I've been doing with this lady since 2016. Her name is Victoria Modesta. She's a bionic pop artist. Young in life, she had problems with her feet. She needed to donate her leg ever since she has been wearing a prosthetic leg. And she's really an advocate for people that are differently abled. So she's trying out like really showcasing her leg, having different shapes and all of that stuff in order to create more awareness that, yeah, having a prosthetic leg is not a shame, but it's actually something that is super badass. And I've been working with her for quite a long time. I think it's 6 or 8 years right now. We created together 7 or 8 legs, and one of them you can see here to the right is the smoke leg. She steps in it. It's the idea of the smoke dress. Smoke comes out. A product called Sonificine, where she's wearing a prosthetic leg with an accelerometer in there. When she moves her leg, she can she can make sound, and she can sonify that sound by the boost that you can see here. You can find that online in Sonifica. And a more recent project that we did was for the company Rolls-Royce, the car company, in where I had the idea to integrate a really small Tesla coil in the shoe and lead that up to towards her leg. So here you can see the shoes. The shoes are 3D printed. It was a collaboration with United Nudes. This is the space for the Tesla coil right here. And basically all the electronics were into the heel. So they are based in the heel of her leg. So here you can see that one. And I think it became the first really tiny Tesla coil, and definitely the first Tesla coil leg. So that's called the Jacob's ladder effect, and here was some of the prototyping. That became a fashion movie, which I can show a little part of. So that is what it ended up with. She also has done like quite a bit of performances in before COVID started with a leg, but it was definitely one of the more complicated projects in terms of many things besides like interaction and all of that stuff. So going back from sort of more the entertainment kind of aspects of where those things end up, sort of going back and taking it back to the body. So I already mentioned the things that I do with basically the surroundings, and I want to connect it back to the body. So you can think of all these cool things that you can measure from the body, from the brain signals to pulse to EMG, so muscle contraction, to EDA, galvanic skin response, to pH levels of your skin, respiration, lung volume is really interesting for emotional data, other than maybe heart rate, HRV, and heart volume, which is a little bit more rational data for me. Respiration is very organic data if you look at it. Accelerometer is place and space of your body parts, temperature, oxygen, and such on. So that is what I explore in some of my other products, like the heartbeat dress is HRV. I'm using respiration for a few of the things, accelerometer in the Sonifica product that I mentioned. And recently I've been doing a lot of things since 2016 with brain signals and using neurotech in order to create almost an input and an output situation. So one of those projects is Aging Unicorn. So it uses an BCI, and it uses these gold-plated electrodes in a headset. So those go through your hair, so you don't need to use any saline or something like that. And basically what I measure is the brain signals. And in the case of Aging Unicorn, I didn't want to create another dress. I wanted to create a device, and I had the possibility to work on a project with Ars Electronica during an artist in residency that I did there. So I created Aging Unicorn, and it was a project based on brain signals. It had a little camera in a headset that looked like a unicorn horn, and I was doing research for with children and children that have ADHD. So one of the points was to make it basically a playful device, which you can see here. I chose the unicorn for that because also of the camera placement and the headset almost. What I wanted to do was create a new kind of BCI, brain-computer interface, that was not super medical. Often if children go through like sort of testing sessions, it's in a white room with this, it's called the 1020 system, 64 electrodes on the head. It's a white room with a doctor in a hospital setting. For the child, that's not super comfortable, but as a researcher to look at these children's data, it's also not super good, because the child is not really being their playful self, you know, because again, it's maybe a little bit an uncomfortable situation in some cases. So basically my critique was like, how can we create certain devices to medical devices that are much more playful and fun for children? So that turned out to be Aging Unicorn. So I was looking at the different signals that I could take, and what the first part was to sort it down to only using a few electrodes. So here you can see the P3 wave of the event-related potential, and this measurement is mainly the one that you want to do if you want to research focus and attention. So it's in the back of the head. Closing it out from 64 electrodes to 8 was kind of good, because it was better to be put into the headset, which you can see here. So here you can see the correlation between the P3 pointers and the headset. And basically, if you're busy with a prototype, first of all, it becomes a little bit a messy prototype, which you can see here, sort of almost a mock-up where the wires are maybe not integrated and you're testing with it. Later on, you're building it in. So this is the final design that it became. So in the back, you can see the sensor placement. In front, you can see the camera. And then also you can see all the controller and the boards, and all of that stuff is in that little slug, but in the back of the design. This became a pretty interesting sort of case study and project. It cuts a lot of sort of attention from the neuroscience community and also from the medical atmosphere. So it's definitely one of my more favorite projects, and also that it addresses a very a certain situation. So what I wanted to do was having this headset to work with the child and being able to track the attention and the focus. And when the focus and the attention went up, the little camera went on, and it was basically recording anything and everything that was happening in their surroundings. And if you are a child having ADHD, the environment has a little bit more effect on you, and that is something that I want to correlate and translate to these children, or to this setting in where it can be discussable, but it's also really interesting for them to see their own sort of brain signals almost fluctuate. So it became this really interesting project where I learned a lot from the children, and they learned a little bit about how their brain worked. The success of this project and the attention that it got actually made me and GTech, the company that I was working with, the neurotechnology company, to bring this out as a device for makers. So it's basically a medical device that is pointed at taking medical data over 8 electrodes, and you can find it under unicornbi.com as the device to work with. And the other thing that we did was inspired by Agent Unicorn. There's also a hackathon called brain.io. Currently it's happening a lot online because of COVID, but normally it's happening in like a lot of cities around the world. So if you're interested in EEG and brain computer interfaces, definitely check this out. And because currently a lot of that is happening online. So one step further was to go from basically that setting of the 8 electrodes. We took it one step further with a project for Ars Electronica to go into this module, which you can see here. One of the PCBs has 16 channels, and combined on the head, this product had 1024 channels that were doing, giving a pretty good resolution of the brain signals. And each of those 1024 channels was connected to a dress. So that's called the Pangolin dress and BCI that we brought out together last year. So it's a dress that basically correlates every signal that is coming in to a movement or a sort of a light and to an interaction within the dress. So you can see when sort of the wearer is more in a neutral state, everything goes blue, it goes more like a neutral, the movement, the flicker becomes a pulse. If you go into more hectic state of mind, the dress starts to like freak out, it starts to blink fast and very irregularly starts to move. And then if you go into meditative state, the whole dress becomes like magenta purple and very flowy and all of that stuff. So taking that really scope of seeing really the whole brain other than Agent Unicorn was to limit the amount of EEG electrodes on the head. Here we really wanted to investigate anything and any resolution that we can find, and that we could do through the Pangolin grid. And so you can find a little bit more on that online, and which might not fully work, and I'm sorry for that. you can find this online. For that, you can see I'm working with little servo motors. So there's the X on the dress, which are like this. If you open them, the servo motors are in there. And then they have like little laser cut plates on there with LEDs in there. So that's the technology behind that. And then, again, this was the bare sensor. Now they're white and capsuled, but this is basically the inside of each of the sensors on the head with little cables. Neurotechnology is just really fun to work with. I think I create an input-output correlation to it. A lot of people do things with music, and I think it's just so unexplored that it's just really interesting to look into that if you have any fascination for working with brain signals. And then, because I'm almost through my time, I think, my last topic is open source. So making and sharing with your community, which I think is always very important. If I collaborate with companies or clients, I would always point them at like, hey, is there something that you want to share with the community that might help them? It can be from codes to some kind of design or whatever they have, sort of, I always try to explain, because companies always are afraid, like, hey, I don't want to open source my company. Like, well, that's not the point. Like, you might open source something that is not super relevant to you, but maybe for somebody else, right? So showing it more as maybe I 3D model a ring, and I just put it on my desktop and it's just laying there, and it's never being printed. While if you put it online, maybe on a website like Thingiverse, somebody maybe like print it out and create a wedding with it or whatever, and be super happy with that ring. So what is that little thing that you have maybe laying around on your desktop or in your files, that you can put online for other people to enjoy? And I think seeing it that way is a little bit better, sort of, really about like making things and then sharing it with your community. So ways to share are like GitHub, for example, for things like code make. You have Maker Faire and this whole community. Thingiverse for 3D files and anything to do with all of that. Instructables is from how to make tomato soup to how to make a robotic dress. The OpenBCI community, Brain Computer Interface, is if you're interested in EEG. It's a community based out of I think San Francisco with Connor. So they're really interested to look into, and also Hackster.io if you're really into hardware hacking. They have a lot of like interesting projects that work with microcontrollers and all of that stuff. So if you go to my Instructables, I definitely need to put more projects on there, but some of the projects that you see, you can go and you can look on how I did them. I share resources, I share technology and all of that stuff. Also on Hackster.io, for example, this tutorial that I do with children, it's like a children's workshop with little kitty ears that light up. So I'm exactly explaining what I'm using, what you need, what kind of software you need to download for it, what you need to get basically, and all the files are free and available. You just need to buy the electronics basically, but I'm not getting any money for this. But really step by step, like basically explaining how to put these together, how to even mill them if you don't want to like print the circuit boards, how you can do that in different ways. And then also how to connect them and how to program them. And for me, it's just really fun to work with, for example, children, to learn them electronics. Mostly what children now have is the technology that they have around them. It's all encapsulated in, it's all cased in. So I like to work with them to really show them microcontrollers and little small electronic components and all of that stuff, because I think that's pretty important to know and to experience with it. So little parts like microcontrollers and sensors and all of that stuff you can buy online. In America, I get a lot from Adafruit. They always have really fun maker-related stuff. SparkFun Electronics, which is based here out of Colorado. In the UK, you have Pimaroni, which is a really cute website, and they have a lot of like boards and all of that stuff that they create themselves for the community. You have DigiKey Electronics for small electronic components and all of that stuff. McMaster-Carr for anything else from tubes to screws and all of that stuff. And then you also have Arduino. Arduino is an open source platform. You can buy an Arduino for 10 or 20 bucks and you can start to like program yourself. You can also, of course, use custom boards. I'm using a lot of Teensies. This was TNC that I created with Paul Stoffwegen, or you can use Raspberry Pis or Feathers or whatever, but you can all find that on these websites. So my name was Anouk Wipprecht, and if you have any questions or if you have a project and I'm looking for a certain sensor or a certain piece of electronics and I can help you with that, drop me a message on social media or write me an email, and I will try to answer your question.